Hi, my name is Zhenmin Chen. I'm assistant professor of biostatistics from Weill Cornell Medicine in New York. I provide statistical support to the college and also do some biomedical research. I also teach a course. It's called Statistical Programming with SAS. And this is for our graduate program. It's called Biostatistics and Data Science. The title for my today's presentation is Reporting Correlation Coefficient Results and the Plots. I'm going to share with you one of my SAS macros that's just for this. This is the outline of my today's talk. First, I will review some background information for this work, and then talk about SAS, how SAS implements the all type of correlation coefficient. And from there, I'm going to show you how I build a SAS macro to report all type of correlation coefficient analysis results in table and figure format. I'm going to show you how what kind of strategy I follow, and this macro is called CORR report macro. I'm going to live demo to you and how to use this macro and what's the expected output. And at the end of the talk, I discuss a little bit about the limitation of this macro. And this is the motivation for this work. So in medical research, whenever there are patient population involved, and usually you need a table one first. And this table one is dedicated to summarize all the information about your population. For example, you want to know the summary statistics about numerical variable. And usually this is the number of patients and mean standard deviation and median range, or even sometimes number of missing values. For categorical variables, it's often frequency and proportion and the number of missing values as well. And this table one usually is a two-way cross table, and all the variables are stratified by a grouping variable, usually is a categorical variable. And then this table often not just for summary statistics, but also it provides the bivariate association information, for example, numerical variable versus the categorical grouping variable. Then you talk about the t-test or ANOVA, or sometimes non-parametric test, or even trend test. And the categorical variable versus the categorical variable, we talk about the chi-square test, sometimes Fisher's exact test, or trend test, or even agreement test. So you have extra column for the p-values. So these are some examples from medical journals. So this, you can see all the variables on the left on the row, and they are stratified by the treatment group. And you see the all type of summary statistics in one table. And also often you need a p-value to test the bivariate association as well. So because this table one is so popular and often must-have table in the publication, so there are a lot of effort spent on this, on building SAS macro to produce this table, and with minimum effort. And in order to do that, you often run SAS procedures. First, for example, you run proc means, proc freq to get the summary statistics, and proc t-test, proc GLM, or even non-parametric proc to provide the bivariate association p-value. And then from there, you output all results and then combine them and then report with ODS. So this kind of macro is very useful in that it dramatically enhance your productivity, and also it's good for reproducible research as well. And there are quite a few such macro published. You can find them, for example, table one macro or GG baseline, etc. And this is from my own SAS macro for table 1. And you can see on the row, those are all the variables names and stratified by treatment group, in this case, placebo and treatment. And then p-value column is provided the bivariate association test result. So this table 1 contains a lot of information. So usually that's good enough. But whenever I prepare table 1, I feel one type of bivariate association information is missing. That is a numerical variable versus a numeric variable. And then you not just want to know the summary statistics, but also you want to know how these two variables are associated. Then you talk about the correlation coefficient. So far, to my knowledge, there's no dedicated SAS macro to report this general correlation coefficient analysis. Also, you can find some specialized one for example, intra-class correlation coefficient, for example, bivariate variable versus continuous variable. So I feel a SAS macro for correlation coefficient analysis reporting is needed. This is just not for practical use. You can get your work much more productive or efficient. And I see this as a teaching example as well. So from building this little SAS macro from scratch, you show the entire procedure from data step, how to use PROC, then how to use ODS output for table and figures, and then how to use macro language as well. And this cover a complete cycle of type of statistical analysis. So this let's review some information about correlation coefficient. The first one and most important one is called Pearson correlation coefficient, and this is basically to describe and measure, describe the degree and direction of linear relationship between two continuous variables, and those two variables should follow bivariate normal distribution. And mathematically, this can be defined as a covariate between these two variables divided by the product of the standard deviation. And we know this population statistics can be estimated from sample statistics. And if you have regression, a simple linear regression for these two variables, then it can also be derived from the R square of the model. And then you put a sign in front of it. So the example data is that it's like patient height versus weight. You want to know the association between these two variables. And the Spearman correlation coefficient is a non-parametric part of Pearson correlation coefficient. So it basically the original value of two numerical variable will replaced by the rank of each value, and then basically use the same mathematical formula to calculate that, and it becomes Spearman correlation coefficient. And the example is that patient survival time after treatment, and you want to know how this time associated with patient's age. And the other very common type of correlation coefficient is polychoric correlation coefficient. And this is a correlation between two ordinal variables. But these two ordinal variables are derived from so-called normal distributed value. And mathematically, this is maximum likelihood estimate of the Spearman correlation coefficient, actually. And the example is patient's quality of life scale, and if you scale 1 to 10, and versus the severity of COVID-19 symptom, if you scale 1 to 5. And the other related correlation coefficient is polyserial correlation coefficient. And this is basically the is for the one continuous variable versus the other ordinal variable. And example of this is patient BMI versus patient's satisfaction scale, 1 to 10. So whatever type of correlation coefficient is always between -1 and 1. And the correlation is stronger when it's more away from 0. And the sign of a correlation coefficient shows the direction of the correlation. If it's positive, then means the two variables are positively correlated. If it's negative, then you say they are negatively correlated. And you can also visualize the correlation between two numeric variables. Many years ago, this paper published talk about at least 13 ways to look at the correlation coefficient. And Rick Wilkling from SAS, he wrote a nice blog some years ago talking about 7 ways to view a correlation coefficient. And then graphically, you can just use scatter plot to visualize the bivariate association between two numeric variables. If the value dot fall on a straight line, means it's more correlated. And if you standardize to a variable, then the slope of regression line is the same as correlation coefficient. So SAS, in SAS, there's a single proc implements all this type of correlation coefficient analysis. It's proc CORR. And so by default, it produces Pearson correlation coefficient analysis. It's often desirable to have a 95% confidence interval of this correlation coefficient, and you can just specify Fisher's Z transformation for that. And often you want to test the different null hypotheses, and you can also specify, and default is 0. And you can just use polychoric or polyserial option to request different type of correlation coefficient. And as other SAS procs, this proc also provide plots as well. So from running there, after you run that proc, this is what the output you can see. So you can see, besides the summary statistics, is also provide the correlation coefficient and the p-value, and also different type of correlation coefficient in different tables. And this is a 2 type of proc it provides. So from there, I want to build a simple SAS macro. So when with minimum effort, a few parameters, you can get a nice table and figure in your report. So this is how I did. So from your SAS dataset, you run this proc, and then just use ODS output, different result to SAS dataset. And then from there, you combine the results of interest to a single new SAS dataset. And then just use proc report to report this in one table. And if you want figures, you can either from original data set, you can use a proc SGplot or proc SGscatter to draw the scatter plot with regression line if you want. And this can be a nice figure. And also you can just directly output the figure provided by proc CORR. And also oftentimes you want the summary, you want the statistics combined with this figure. Then you can just create SAS macro variables from data step and then combine it with your figure. And you can wrap up every of these steps into a macro and call this CORR report. So this is how to use the macro. It's very simple, only 3 required options, dataset name and variable names, and others are optional. And you can request different type of correlation coefficient and different null hypothesis to test. Default is 0. And you can also, optionally, you can request the plus. And default is null plus. But if you want plus, and you can also use different option to further customize this to suit your publication needs. So this is the example outcome from running this macro. So this is a table, and you can see it has all the variables on a row, and it provides the summary statistics, and then this is the correlation coefficient with the 95% confidence interval. And then there's another column to provide the statistical test results. So the added feature here is when the p-value is less than 0.05, it's labeled as red. And under the table, you will see notes help you to interpret this correlation coefficient. You will see it's a strong correlation or moderate or weak correlation. And this is the figure. It's almost a publication quality figure, and you often see the statistics are included in this figure. So this is the full report from running one of my project. So you can see this table just for 2 variables. And for 2 variables, you're going to see the nice plot with a regression line as this. And if I have multiple variables, then everything will be in one table, and it's going to provide you a panel scatter plot if you have multiple variables. And this is a Spelman correlation coefficient. And this time, I test the null hypothesis R equals 0.5. So you can see the p-value is different. And also can request the plot. And this is a polychoric correlation coefficient in the same similar table. And this is for polyserial correlation coefficient between continuous variable versus ordinal variable. And also can request the plots. So this is the SAS code that just produce that report. So once you prepare your data, then you use include to call this macro, and then I often use proc RTF for my report, and then followed by a bunch of SAS inline formatting, and then you just use the macro. So in this way, and you can request you request different table in the same file like this, and once you run this, you get that report. So that's the macro I built. It's very simple and easy to use, but the limitation here is there's no customized error message yet. And also for other type of correlation coefficient, also they are not as common as the one I showed you. For example, Kendall's tau, partial correlation, or Cronbach coefficient alpha, but it can be easily included in there. So takeaway from my this presentation is SAS is very comprehensive in correlation coefficient analysis as other type of analysis. And the SAS macro is very powerful tool for you to efficiently produce results and report your results in table and figure. And this not just a very useful tool in real world practice, but also is a teaching example in classroom. And it basically covers a complete cycle of data analysis involved in correlation coefficient. and use SAS alone. And the skills built from this macro are very extendable to other macros as well. I stop there and thank you for your attention.